PyCon APAC. This is one of the most exciting things that I think I've done all year, is the ability to come here and see an entirely new to me branch of the Python community. I'd like to, if everyone could give a hand to the organizers who have done such a great job. So Python is 25 years old, almost exactly. The very first bits that became Python were committed by Guido in the Netherlands in late 89 or early 90. So and since then it was publicly released in 91, and it has grown to what we see today. Now, 25 years old is older than some of the people in this audience. It's younger than others, and it's just about the right age to come here to the university, or come here and participate in an academic setting and see what it is that we've learned in 25 years. And I'd like to talk in particular about the things that are going right in Python, and also a lot of the things that are going, well, not, I wouldn't say wrong, but are threats to the Python ecosystem, because they make it harder, they may make it harder for us in the future to do the things that we love. So the first question is, why do I say the Python ecosystem? The term software ecosystem was coined about 10 years ago in a book by two authors who were examining the economics of different systems. And they had a theory associated with this. A lot of the things that they proposed didn't catch on, but that one term of a software ecosystem did. The way in which they described it and the way in which it has evolved, it has come to mean the community of not only developers, but corporations, of organizations, of users, all these different people working together in a common technology. This idea about a software ecosystem, particularly in light of the open source movement, has become so prevalent that there is one particular analyst named Redmock who named his blog Techisystems, because he said, all technology is just an ecosystem. Now, we could spend some time celebrating the strength and the breadth of the Python ecosystem, because that is one of the things that we really have going for us. It was 10 years ago that Paul Graham, who you may know as the founder of Y Combinator, wrote the Python Paradox, in which he said, people don't learn Python because it will get them a job. They learn it because they genuinely like to program and aren't satisfied with the languages they already know. It makes them exactly the type of programmers that companies should want to hire. Hence, for what of lack of a better name, I'll call the Python Paradox. If a company chooses to write its software in a comparatively esoteric language, they'll be able to hire better programmers because they'll attract only those who cared enough to learn it. And for programmers, the paradox is even more pronounced. The language to learn if you want to get a good job is a language that people don't learn merely to get a job. Isn't it funny that just a few years ago, Python was considered relatively esoteric, not very common, and definitely an underdog choice? This is one of those things that we have lost, is this ability to be the up-and-coming language. Instead, this is actually one of the recent rankings of programming languages on that blog that I mentioned, where they took a look at Stack Overflow, and they took a look at GitHub, and they cross-referenced the most common languages for all of those projects and all of those questions, and they said, what are the most common Tier 1, Tier 2, Tier 3 languages? And as you can see, we're right there at the top. So this is something, again, to be celebrated. But it comes with a price. Or let's take a look at the same data another way. How many here ever had to use Perl? quite a few. 10 years ago, or 15 years ago, Perl was the undisputed king of the dynamic language space. This is a graph of the relative popularity of Perl and Python from 2004 through 2013. You can see that while Perl has gone down, Python has gone up, but we've plateaued. Now, this is not to say that other languages need to go down for Python to be successful. I think that there are lots of different ways in which we can all work together, and in fact, I think that the more people learn to use code as a way to engage with their computers and to engage with their phones and to engage with all the computing that is around us, the better off we are. But it is telling that we have reached a point where we have broad use across many different sectors. But that doesn't mean that we don't have issues. I think that one of the biggest issues is the transition from Python 2 to Python 3, where we are trying to take this big ecosystem and we are trying to move it from one version of the language to another. I am firmly convinced that the majority of the community will be moving over to Python, probably over into Python 3, over in the 3.4 to 3.5 timeline. There are enough projects and libraries that have moved over to make it easy to port. We know as a community how to do this porting. But I also know that there are some projects, particularly ones that are deeply embedded, that will never move off Python 2. So this is definitely a stress for our community, but it's not one that I'm necessarily here to talk about. Instead, even though this is a stress on our community, it's all Python. It's still Python 2. It's still Python, even though it's Python 2 versus Python 3. What are the threats to the broader ecosystem of Python programmers and corporations? And then if we need to look at that, we need to start looking at other languages. And I believe that there are three primary threats that we need to be worried about. So they are Java, JavaScript, and Go. Now, how many people, just out of curiosity, are or have written in one of these languages? This is what I'm saying. If you compare with the people who have used Perl, these three languages are either as broadly entrenched or as widely used or are up and coming. But let's take a step back. Why do we care about this? You may say, who cares if Java or JavaScript or Go become important or widespread? Well, I think that the first and the biggest reason is because it has to do with the economics associated with open source development. Open source development is a collective measure where we all agree to join in the participation of this community. We trade intellectual property. You do the things that you do well, I do the things that I do well, and we trade it through the medium of these open source licenses. When we do this, we engage in trade, and it benefits everybody. The problem is that that virtuous cycle only continues as long as there are a wide number of buyers and sellers, i.e. people who want to engage in the ecosystem and trade knowledge about Python. If you have a decreasing number of people who want to invest money and time and effort into Python, then you get what's called an illiquid market. There may be people who want to do this, but they can't find others to engage with. And as a result, the total size of the investment in Python shrinks. If that happens, that means that it is harder for us to have conferences like PyCon APAC. It is harder for us to have jobs where we do Python. Now, do I think that this is a imminent threat? No, but this ultimately is why we care. I also care because these three languages in particular have a particularly difficult issue in that they are harder to interoperate with. This is true more so for some of those languages and less so for others, and I'll get into that. But for each one of these languages, they tend to be an all or nothing affair. For example, Java, while you can technically shell out and call programs in other languages, it strongly encourages that everything be running on the JVM, if for no other reason than the JVM takes 12 years to start up. And so everything you do means that you really don't want to ever throw away that JVM ever again. For JavaScript, it has the security model that was originally built around the web and its ubiquity associated with the web, which means that you can't expand the scope of JavaScript very fast without giving away its largest advantage. Therefore, people tend to port to JavaScript and not port away. And finally, Go doesn't even have the concept of a library that you can call. Any of the things that are Go libraries are simply things that are textually included in the statically linked binary. When you do this, any code that is written in Go, for example, just as with these other languages, ends up, for me, as a Python programmer, as essentially dead code. I can't interact with it except with over the network. This means that code that goes into these other ecosystems can't interoperate with us in the same way other languages such as Fortran or C or Rust can do. So let's go back and let's talk about what these languages are doing that is good and what we are not doing that is leading them to gain users at our expense. I don't know how many have been to a DJCon, but they have a tradition that every year they have a keynote that says why Django sucks, why it is bad. I think that is actually one of the healthiest and most wonderful things about DjangoCon. And so this ecosystem threats to Python, I'm going to talk, it could be subtitled Why Python Sucks and What Other People Are Doing Better. So let's talk about Java. Java has always been a broad and difficult and rather interesting community. It's capable of doing very surprising things. It started out, as you know, as the Oak embedded programming language, and it received a mid-early life course correction when this newfangled thing called the internet came up. And Sun decided that they would make a deal with Netscape that they would embed their language in the browser and it would become the almost exclusive language of the browser. That almost is important, and you know what the other language of the browser came to be. Because of this, it suddenly became the subject of lots and lots of development in places where it was never originally meant to go. But if you look at, as a result of this broad adoption, though, that was sort of forced on it by its corporate parents, who really wanted to drive the adoption of this language and the standard around it, Java has always had this corporate behemoth, many corporate behemoths behind it, which means that it has been the largest portion of the technical book market almost every year since the early 2000s. It has had more money spent at Java 1, at a single Java 1, than at all Python conferences since the beginning of time. This is a scale that we simply can't match. But it is not only that. Java has also become one of the core languages of the open source movement. It is, to the extent that there is an official language of the Apache Software Foundation, which runs a surprising amount of the infrastructure software and manages it in the entire world, frankly. Many of those, and it is their official recommendation to consider doing them in Java. And so as a result, it becomes a teaching language as well for those who are interested in engaging with the open source ecosystem. But I think that the biggest thing is the number of man-hours that have gone into the Java virtual machine. So the Java virtual machine we can think of in many ways as a crown jewel. It is optimized for certain types of workloads. I mentioned it takes a very long time to start up. I swear I can feel the hamster start running in his cage every time you need to start up something that requires Java. But once you have got it started, Java, because of the many hundreds or even thousands of man-years of development that have gone into the hotspot and JIT technologies, can be very, very fast and can be very, very just within a couple percentages of C, or sometimes, if you use the right structures, even faster. That is something else for a language that is entirely managed and gives, while not great, pretty good security precautions due to its sandbox model. Because it has this highly performant and fairly expressive JVM built upon a bytecode, you see lots and lots of languages that are not Java actually building on top of the JVM. For example, one of my favorites is Clojure, or Groovy, or Scala. All of these things, if you look at Wikipedia, I think that they list something like 67 different languages that all target the JVM as their underlying runtime. If we were that rich in terms of an ecosystem, we would be doing a lot better. I also think that you can't stop there. You have to look at the importance of Java in mobile. Now, mobile, it becomes almost trite to say how much it is affecting computing these days. I think that the rise of mobile is entirely the reason why Objective-C is not in the dustbin of history. And it has been the major driver toward the adoption of Java by new amateur programmers the world over, because everybody is trying to get their apps onto Android, which uses Java as its primary runtime, or at least the interface to its primary runtime. Android allows developers to combine these different pieces, the open source elements from the Apache Software Foundation, from other developers, with its own APIs, to create new and powerful things. And Android, in particular, is going places where no other embedded operating system is going. Yes, Apple has a very significant market share, majority in some cases, but they are not licensing it out with the same breadth to allow the broader ecosystem that in Java that Android is driving. And finally, there is the idea of data. Well, actually not quite finally. There's the idea of data. You all know Hadoop, of course, or Storm. Almost all of the current batch of big data analytics products are built on Java. This makes it a bastion for them of strength, where they are really driving the industry. And as much as it pains me to say it, there is a hackerness to Java. Now, I was telling a few people last night that some of my early academic instruction was in Java, and it really rubbed me the wrong way. It was because of Java that I came to Python, because I liked it so much better. But there are an amazing number of very foundational things that originated in the Java ecosystem. For example, the Ant replaced Make. It was the first major replacement for Make. I think it anticipated SCONs, which wasn't as broadly adopted. It's then gone on to Maven. JUnit was, I think, the first widely used unit testing environment. These are sorts of things that have been adopted by other programming languages, including ours. These are good ideas, and they were driven by hackers, experimenters. These are the sorts of things that drove the Java ecosystem. So what about JavaScript? Now, JavaScript was that other little language that they put together into the browser. You'll notice that two of these ecosystem competitors were launched by the ubiquity of the HTTP-powered internet. I was talking actually 2 days ago with Glif Lefkowitz, who is known to a lot of you as the originator of the Twisted Python framework. And we were talking a little bit about JavaScript, and he said, I'm a little worried that JavaScript is won and we just all don't know it yet. That was a very powerful statement to me because he was talking in broad terms about the same idea of the ecosystem. What makes it so powerful? It is the fact that JavaScript is on every single device everywhere that has a UI, almost without exception. Increasing numbers of devices are being powered up for the express purpose so that they can use JavaScript-powered UIs, because the web and HTTP-powered protocols are taking over everything. There are many pieces of perfectly good legacy technology and legacy protocols that are being subsumed by HTTP because it will get you through a firewall. It'll allow you to traverse the internet, and it will be reasonably interoperable without lots of problems. These are huge network-driven advantages that we just don't have in the Python ecosystem. Being embedded in that browser was the first and best thing that ever happened to JavaScript. I also have to say that I think the second thing that happened that was good to JavaScript was Gmail. How many people remember when Gmail first came out? This was an amazing product. We look at it today and we think, this is just Gmail. But when it came out, JavaScript was mostly limited to this idea of doing rollovers or light interaction on a page. Google transformed the world in two ways. First, by saying you can have a desktop quality experience in JavaScript and in the browser. This was something that had never been seen before by anybody, and people flocked to it and loved it because it was available everywhere there was a browser. In tandem, they also developed Chrome. And when Chrome was launched, they said the number one thing that Chrome has is it has two advantages. Number one is speed. Number two is security. And that speed is entirely about JavaScript speed. And it started a huge arms race between Apple with Nitro and Squirrelfish. Even Microsoft got into it. I forget what their engine name was. Firefox with their number of monkeys, their Spider Monkey and Ion Monkey and Trace Monkey. They got so that this very, very clunky language actually turned out to be, on a whole, half as fast as C when you treated it right, which for a language with roughly the expressive power of Python is astounding. They got half the speed of C out of something that looks, in a lot of ways, like Python and is being continually inspired by us. I don't know if you have seen some of the things that have come out in ES6 or ES7. A lot of them were directly inspired by the iterator and generator concepts that came out in Python first. Finally, there are a couple things that made this a good fit for the increasing areas in which JavaScript and computers were used. Computers are increasingly networked. I mean, it gets to the point where if I don't have a network connection on my laptop or on my phone, I'm not even sure what to do with it anymore. It used to be, in the old days, that I would only occasionally dial up and I would do my online interactions and then I would shut down and I would have things to do on my computer. Those days are past. Today, we all depend on network connections being live almost all the time. Now, network connections are inherently going to be laggy. They take an unknown amount of time and they may or may not succeed. And so the traditional model of send out a response and wait for it just didn't work. Instead, they developed this idea of a completely evented asynchronous communication model because everything was driven by the click of the user or by the network delivering things on a very bursty, not very predictable schedule. Everything in JavaScript was built around this idea of an evented asynchronous system, which meant that even if you could do it in other languages, this was built into the language from the ground up, and it made it very, very easy. The other thing is that they said, we need a way to define safely a transport format. And so they came out and they said, let's just define this subset, and we'll call it JavaScript Object Notation, or JSON, and we will define this as our transport format. In some ways, it sounds crazy, because if we were to say, let's ship pickles, the equivalent of, let's ship raw Python code or pickles over the internet, and let's just eval them every time we wanted to get that information back, people would look at you like you are crazy, because it is not safe to do in Python. We didn't build in the same source origin policy, the security model, to allow that. We said, we want people to be able to do much more, and as a result, we ended up being able to do a little bit less. It got to the point where in Python, we support JavaScript as a serialization format. If you think about it, that's a little crazy that we serialize to another dynamic language in order to communicate with other services. Finally, when this came out of the browser and people started to be able to use the same language on the server and on the browser, and because of this idea, I can just send JavaScript back and forth and have it be evaluated and share my state and share my structures between my client and my server, all of a sudden, that became a tremendous driver of new functionality. So you started to see new projects coming up in Node and IOJS, which is now they're going to merge, and all sorts of people saying, this is really, really interesting. We're going to try and drive these things through JavaScript. It became a desktop, not just a web browser language. And I think that the final form of this is actually coming in the Firefox OS, in which every single interaction is designed to be scriptable and manipulable and available to JavaScript. Where Firefox OS, yes, it is a webby OS, but it is ultimately designed around the interaction and control of hardware in a way that is much more like a desktop or much more like a thick client than it is like a browser. JavaScript, for no other reason than these powerful network effects and its ubiquity in every single browser everywhere, has the widest distribution of any language anywhere in the world. Now let's talk about Go. Now, Go is a little bit difficult because in some ways this is the one that worries me the most. With Java, we have, to a certain extent, embraced Java. There were just a month ago, I think, there was a release of the 2.7 compatible branch of Jython, which coincidentally was the first version of Python that I ever ran, was Jython. They are now working on a 3.4 or 3.5 compatible branch, and they think that they'll get there within a couple years, and they'll continue to move forward. with JavaScript, there was an amazing demo at PyCon this year where people could compile a full Python interpreter using asm.js and in Scriptum to run in the browser and to properly control and do all the things that JavaScript can do, but with a very distinctly Python console having Python semantics. We have carefully and with difficulty learned to engage with these other languages as well as we can. But Go is uniquely difficult. First, Go only has static binaries. This is due to its design purpose for creating Unix servers that run on something. It's much easier to just drop a binary and go. That deployment is beautiful. That is something that is so much easier than Python, it's almost unimaginable. How many here have needed to do deployment of a Python application? A couple people. Is it fun or is it painful? Painful, yes. With Go, you don't have to do any of that. You just push it and it runs. That's something that we simply can't match. Also, Go has been designed from the bottom up for multi-core concurrent use. Tell you a little story. There is a project called OpenStack that is widely deployed. It's one of the primary drivers of my employer, Rackspace. OpenStack is almost entirely written in Python. But starting last year, we had a little team within Rackspace that started experimenting, what if we rewrote some of these core elements in Go? And when they did, they found that they had from 5 to 11 times speed up. And this was for a couple of reasons. The first was because Go is closer to the metal. A lot of the metaprogramming techniques that they used in Python, they figured out how to get rid of them. And so they created a lower level, albeit possibly not as pretty, but acceptably working interoperable binary. The second thing, though, was that they were able to take a 24-core server and completely saturate it when using the disk to schedule, when using all these to schedule active network activity and active disk activity. This was something that they tried in Python, and while they could do it, it was very, very difficult to correctly and in a performance-sensitive way have all of the cores be used. The best that they could do was to run several different workers in parallel, and then have some other program in front of them trying to dish out jobs as they came. In contrast, when they wrote this prototype in Go, all they needed to do was create a Go routine handler and a Go routine, and they transparently saturated all of the CPU on this box, and as a result, they were able to sustain not only 7 times better performance, but they were able to sustain it on the most difficult types of workloads that this server saw. This is a very substantial problem because right now in Python, we don't have a good multi-core story. The best that we've got is the work that is going on with Armin Rigo and the PyPy R&D team, who are working on libstm. The other way, that's the pure Python version. There are other people who are working on trying to retool the interpreter. There are others who are saying, if you really want high performance Python, you need to actually do it in Java, because Java can use all of these threads, and in certain cases, a Python application running on Jython on top of the JVM will run faster because of this ability. this is something that is actively driving people away, because 25 years ago when Python was created, the idea of a multi-core CPU was so far off as to be not worth thinking about. So the way in which they designed Python was to make it easier to read, to extend, to develop, which was the right decision at the time. But when Go was first announced in 2010 or 2011, at that time, the average processor was dual core or more. And because of that, they designed around a new set of assumptions. They designed around 64-bitness, they designed around dual core, they designed around asynchronous communication, and they made it so that it worked beautifully, idiomatically within the language. So I've now talked for a little while about, I didn't even talk about my reasons for why Go. Go is a wonderful language. It is pragmatic and small. It fits your brain in a similar way to Python. One thing that it has going for it is this idea of high-level data types. You have very Python-esque dictionaries and other lists and strings and things that feel relatively high level. The only thing that feels absolutely backward in Go is their error handling. They, once and for all, solved this idea of how are you going to format it by simply saying, go format. And that is the official style, and we will make sure it works all the time, every time. And they even got to this point where the interactive experience, even though it was compiled, was so fast that people expect Go run to be a command line experience. And they're sometimes surprised when they're coming from Python that they can't go back and immediately reevaluate the things that they just wrote because it feels so immediate. I think I talked about these other things. So now let's turn for a moment to Python. Now I said, let's talk about the things that we're doing wrong. I think that you could put them generally into 3 buckets. You could put them into the multi-core, mobile, and package management. And those are the things that these languages are doing as a whole better than we are. They also have some unique network effects. But we also have some things that we are using to push back. The first is this idea of a broad ecosystem. With the possible exception of Java, Python has, I believe, the broadest ecosystem of all of these languages that we've talked about. If you look at Ruby, it is absolutely tied to Rails or certain system administration things. You look at Perl, it's very system administration heavy. JavaScript, even for its success in other places, is very much still an in-the-browser web language. Go is highly tuned for its key deployment of small Unix network servers. And even though they're looking at trying to add support for it to mobile phones and Android and things like that, it still has, they each have their places where it's a stronghold and they are reaching out, and sometimes at our expense. In contrast, Python, it is hard to say where Python isn't. In fact, there are whole industries where the standard interfaces are in Python. Probably my favorite example is in the special effects and animation industry. This was something that is widely known within the industry, but I don't think really widely known outside, is that when you look at a movie, it is almost every movie today has had the data structure, the data that forms the special effects ran through Python. Every single major animation studio, every single major special effects house uses Python from one end to the other to run their entire animation and special effects pipeline. They call out C, they have other different places where they do the heavy-duty crunching. but to move it around, to make it work, it's all Python. Python has huge strength in the scientific computing industry. There was someone from Khan Academy who was talking to me where they said, we'd really like to do our scientific computing courseware in JavaScript. But the problem is no one is interested in doing scientific computing in JavaScript. And so we feel like we have to support Python because that's where everybody is. This is one of the things that gives such breadth and richness to the Python ecosystem is that we are everywhere. Similarly, like Go, it is easy to understand. I'd like to take 1 second and talk about the ethics of computing and how that ties to how easy it is to understand your code and why this is important. When you write code, everybody has bugs. Certain people have more, certain people have less. But every bug that you write creates what's called a negative externality, a cost that is imposed on other people. Sometimes it's imposed on your users, sometimes it's imposed on your company, sometimes you don't know who it's imposed on. But that bug costs other people time and money, could cost them their data, could cost them all sorts of things. And we have the ethical responsibility to try and make our code as bug-free as possible. Good readability counts in doing that. Good readability is an ethical thing to have in computing because it reduces the costs of what we do upon other people. That is a positive good in the world. We can't lose that. That's why being Pythonic is such a powerful and an important concept and why it is central to this idea of being Python. We also have this idea of Python being a teaching language. One of the most exciting things to me that is happening right now is not only do we see universities right and left across the world converting to Python, but the PSF was actually approached by the BBC and the government of the UK to make sure that when they launch the BBC Microbit, it's an embedded little computer that is going to go out to every 11-year-old in the UK later this year. They wanted to make sure that Python was on it because Python has become, in many ways, the de facto teaching language for all kids in the UK. The UK is actually the place in the world that is the farthest ahead of this, and they are actively embracing Python for all their students all over the place. That means that if Python is the first language you learn, well, you could be like me, where I learned in Java and I immediately turned toward Python. But I think it's more likely that Python will be that thing that people turn back to. Maybe they use other tools for other jobs, but Python becomes the core tool in their toolbox. I also want to highlight what I call the PyPy R&D division. They just released CFFI, which is honestly the most beautiful way of interacting with external libraries and external C code I've ever seen. It's easy. You should try it if you need lots of speed and you want to call out to a library. It's beautiful. They're working on libstm. They've taken PyPy and they have thrown multiple PhD level efforts at it to get it to about that same 7 times improvement that this other team in my company got from using Go. Is that in every case? No. But they have done an incredible amount of work optimizing and creating a fast and compliant Python interpreter. And they've done it to the point that other languages have started adopting the PyPy, our Python toolchain, as the basis for their own language, which is us starting to walk down that same road that Java has of having Python hosted other languages. That's a very positive thing. And it's something that I don't see in other languages simply because they are driven by those corporate interests. Yes, they're putting their money into it, but this open source, open science research is something that is very much tied to Python. And finally, Python 3, it's a great language. it is one of those things which, even though I mentioned it as a stressor, it is actively opening up the ability for us to do lots of new and exciting things. And I think that it is actually one of the sources of strength. That brings me to the final slide, and this is the very most important thing about Python, is that Python isn't just the language. Python is the Python community. I was talking with a few people from several different countries last night, and we were talking about language difficulties and interactions. And I believe it was Young-Yu who said, but we all speak Python. We may not all speak English really well, but when we put up some code, when we're talking about the computing concepts, we all speak Python. I was very happy to see that last week we elected a new board of directors that had the broadest representation of any open source group in the world in terms of different types of people with different types of backgrounds from different places. It wasn't just, you know, the same 10 people all in a room. And the reason why that is so powerful is because the growth and the power in the Python community ultimately comes from the people. The language is a tool to allow us to communicate, to allow us to interact, and to allow us to do all these other things that enrich our lives, that enrich others' lives, and make things better in the world. The Python community is the most important treasure that we have, and it is the thing that is expanding faster than any other community. And it is the thing that we need to keep on investing in day after day, year after year, to make sure that we can, to make sure that we have a viable platform going forward. So, in the last couple minutes I have left, I want to encourage you to do a couple things here at this PyCon APAC. The first is to find the people who took their time to make this conference for you and say thanks. Find someone who wrote a library that you use and say thanks. Try and serve others. Try and meet others. Be empathetic and compassionate, because when we reach out and we lift each other up, those are the sorts of things that will bring in new people with new ideas and will make us stronger each and every day. Thank you very much.